Welcome everyone. So today is our one more Sunday when we are solving LeetCode and doing system design. So I think previous Sunday we did also a bit of LeetCode, one follow-up question we didn't solve last Sunday. And also we did a system design of a real Amazon question that I was asked once during the first and maybe the last interview at Amazon. So yeah, today the agenda is pretty much the same. Make yourself tea. I don't know. You can proceed. For those who are first time, I'm software engineer at Microsoft. Today we are in the office, and last time I was solving LeetCode questions and preparing to interview 3 years ago, right before I joined Microsoft, and I feel like I lost my skill at the moment. So we are catching up, and that's why I'm recording this stream, so you can solve the problems with me and improve yourself. Also, if you have any questions about like this big corpo, Microsoft and stuff like that, I'm here to answer them, of course. So yeah, but mainly we're gonna just solve LeetCode and doing system design. So yeah, agenda is 4 or 5 problems in LeetCode first thing, and then one LeetCode problem as a follow-up, since it was asked during the previous stream. And then we are doing LeetCode of rate limiter, the basic problem, basic system design question. Not that hard, but pretty much interesting. I never was asked this problem. I think it could be cool experience to design such thing. So yeah, that's it. I think 5 minutes already passed. So yeah, again, make yourself tea and let's go. So last time we stopped at the find pivot index, and now we are moving to topic hash map and hash set. This thing. So yeah, we're basically gonna solve these 4 problems and maybe this one for the stack topic. And then one more problem that was asked before. It is related to priority queue. Let me find it. Yeah, I think that's it. Yeah, this is minimum operations to exceed threshold value 2. This is the question that was asked in the comments, I think, from the Twitch last stream. So we're gonna solve it as well. And also, I also tried to mathematically prove another algorithm that fits here, because this question actually can be solved without using a priority queue, but a bit in a smarter way. So yeah, I think we can go. So first question is easy one, find the difference of 2 arrays. So pretty easy one. Let me also monitor what's going on the stream. Good. So given two zero-indexed integer arrays nums1 and nums2, return a list answer of size 2, where answer 0 is list of all distinct integers in nums1 which are not present in nums2, and same one but vice versa. So in this case we are given 1 to 3 and 2 4 6. We should return only the numbers in the first array that do not exist in the second array, and vice versa. So 1 and 3 do not exist at nums2, and 4 6 do not exist in nums1. So basically pretty simple question. We have nums1. Okay, I need to zoom a bit. We have nums1. It has some numbers, right? I think I can do here nums1, and we have nums2. Let's put it as a red nums2. So we're gonna intersect them, and we want basically to remove all the intersected numbers. So how gonna we do it? So first of all, we should know which numbers in this array and which numbers in that array, and we should be able to quickly assess whether some particular number in nums1 exists in nums2. So let's first populate, we can use basically set for this. Let's populate the two sets. So set1, no, we're not gonna use this window. Let's do proper vim. New file, please. This is how we are going to do it. Good. So first, we are creating the set for nums1. Hello, welcome in the stream. And here we're creating another set. Now, these two sets can answer us the question whether some number exists in this set or not. And this is exactly what we're gonna do. We're gonna traverse the number and populate the answer. So let's just traverse the number of first array. And in case any number from the first array does exist in set 2, we should not include it. We are just basically removing this intersection by doing this. So if set2 has num, we just continue. We should not continue. We should straight away delete this number from both, from nums1 and from nums2. So set1 delete num, set2 delete num. Because since this number exists in both of them, we should remove it according to the problem description, right? And after that, we just return array of size 2. So let's do it an array. I think there is from exactly, and set1 array from set2. That's it. So two test cases passed. Yeah, pretty easy problem. The time complexity here would be so creating the set here and first of all, nums1 length is n and nums2 length is m. In this case, the time complexity would be first we're traversing n by creating set 1, then we're traversing m by creating set 2, and we're traversing n again here, and delete and has operations for the hash set or hash map is constant. Also, we're traversing it once more due to this array from. But this is kind of response, so I'm not kind of sure, because actually we can return sets as a raw value, right? We just obligated to return it as an array, but set itself is also like already a collection that you can use as an answer, so this kind of could be omitted. So in this case, I would say time complexity is big O n plus m plus n again due to this for loop, which simplifies to just big O n plus m. And space complexity, what would you think it should be? We are creating two additional sets with the lengths. So nums are numbers. They can be like from 0 to, I don't know, to max int or to max long even, I'm not sure. So in this case, we're gonna just state that we are creating n plus m, considering then that all numbers in these two arrays are unique. Good, good. Let's move on. A unique number of occurrences. Given an array of integers r, return true if the number of occurrences of each value in the array is unique or false otherwise. Oh, this is pretty trivial question. So we have 3 1s, 2 2s, and 1 3. And in this case, if we have all occurrences are unique, so we return true. And in this case, we have only single 1 and single 2. Since we have two same occurrences, we just return false. So we need just to count occurrences and then just answer the question whether there are any two same occurrences. So let's just traverse the array of numbers, right? It's numbers. Array. Yeah, once more. Why am I using this LeetCode window? So to collect and to accumulate the number of occurrences that we have here, the easiest way and just a simple way is to just keep our map. So map is a set data structure that can give you very good and tasty time complexities for accessing time, because this is a hash map, and specifically map can also store value for the key. So our value in this case would be the number itself. This is going to be the key. The key is going to be a number, and value should be the number of occurrences that we encounter this number. It should be set, right? Yeah, so we're setting number, and we are setting it to what? Initially map is empty, and if it's empty, we want to add the element, and if the element is already here, we just need to increment the number of occurrences, right? So initially we want to create it with 0. So let's say it should be 0 or map get num if we previously already met this number, and this one we want to do +1 always. So in case map is empty, it would be 0 + 1 = 1, and we are setting it initially. If it's not empty and map has this value, this key, we just increment it. So that's it. This won't work because 0 should be always true. Yeah, like this. And now that we have the occurrences, we now should just check whether there is already some another occurrence of that is already in the map. So for this, we're gonna use set. Set can contain only the keys, which we are particularly interested in at the moment. So we're gonna traverse all the values in the map, and values are occurrences, if you remember. Occurrence of map values. Yeah, and if set already has occurrence that we added previously, we should just return false. Otherwise, just set add this occurrence. If there was 0 times that we encounter the same occurrences, we return true. Let's test it. Test cases have passed, good. Yeah. Also pretty trivial problem actually. So let's move on. Determine if two strings are close. Okay, this problem is pretty interesting, I would say. So two strings are considered close if you can attain one from the other using the following operations. Operation 1, swap any two existing characters. For example, A, B, C, D, E can become A, E, C, D, B because we swapped B and E. And then operation 2, transform every occurrence of one existing character into another existing character and do the same with the other character. So for example, we have two A's. Yeah, oh sorry, we have three A's here, A, C and A, so three A's and two B's. And we can change it to three B's and two A's at the same places basically. So yeah, all A's turn into B's and all B's turn into A's. You can use the operations on either string as many times as necessary. Given two strings word1 and word2, return true if word1 and word2 are close and false otherwise. So we should return true in case we can build up word2 from word1 using these two operations. So whether we can convert word1 to word2. And here are examples. This one is too simplified, I would say. So A, B, C, we are swapping B and C, and then we are swapping A and B. So we are applying only one operation, it's not that interesting. But in the end, yeah, ABC becomes BCA. This is simple case tells us that if we have strings with different lengths, I don't think we can proceed. In this case, we cannot. And this is a bit more interesting example. So in this case, what they do is first change B and A, swap them basically, and then convert all B's to C. It becomes BAACCC, and then we are doing the same with A's and B. So B becomes A and two A's become two B's. Okay. This problem took a bit of my time previously, and acceptance rate 50%. So let's break down our problem a bit. So first of all, we for sure can say that the lengths should be the same. What else we can say? Basically, swapping like the thing that they allow us to swap two characters means that basically we can reorder characters the way we want. So we can swap any two characters and it will be not a problem. Oh, Igor, hello friend. Hello everybody. We have, how many people are watching us at the moment? 7 people. Good. Last time I think we had almost 10. Not sure. So yeah, for those who just came, we are doing LeetCode, and after 2-3 more questions, we're gonna proceed with system design of rate limiter, the basic algorithm. Oh, sorry, system design problem. Yeah. But first, let's figure out this close strings problem. Vlad, hello. So guys, actually now in the stream we have 2 people that are also worked at Microsoft, my friends. Who is Vlad 10? Vlad 10, by the way, is celebrity in post-Soviet countries. He's Russian speaking. But please Google him and you will find him. He's doing very interesting, I would say, show or news podcast. So you can find it interesting. Highly recommended. I think my link was just shared somewhere. Most probably either Vlad or Igor just shared it. Thank you guys. Because 60 people, I don't think this channel ever had 16 people watching us. Okay, now it's 20, I think, yeah. Okay, we have some activity definitely right now. Thank you, Vlad and Igor. Yeah, these are my friends and ex-colleagues at Microsoft. They were working here, and then they decided to change their path. And I'm still struggling here, maintaining the stocks. So, yeah, somebody has to do it. Okay, I see. Yeah, sorry guys. The stream is English speaking. I could do Russian or Ukrainian, but due to political reasons, I'm streaming only English, unfortunately. But I can understand your questions and your comments. Thank you guys. Thank you. Okay, so yeah, for those who just came, I think, yeah, yeah, it can be. So yeah, I'm software engineer at Microsoft. Vlad and Igor are 2 my friends. Yeah, ex-colleagues at Microsoft, and in this stream we are solving LeetCode problems, and later on we're gonna do some system design. Yeah, so let's start basically. Yeah, thank you. Thank you. A bit uncomfortable because legit this channel never had more than 10 viewers at the same time. So yeah, here we are preparing for the interviews, because exactly 3 years ago when I was preparing for Microsoft interview, I was doing same thing. So just preparing LeetCode infinitely and doing system design. So this is what we're gonna do exactly here. So this is the question, and now we want to determine if 2 strings are close or not. We just reviewed the problem. So what could be the thinking process in this case for us? Basically, first conclusion is that 2 different lengths cannot fit us, because yeah, the 2 words should be the same length basically. Why you use fork UI for Git? Well, because I'm not quite used with the command line for Git, unfortunately. I'm quite used to command line in general and to terminal, but for Git, I don't know, 6 or 7 years when I just started. First I think Git Kraken or something like that. Then I switched to something from Bitbucket. I don't really remember. Maybe Source 3 it was called. And then in the end I switched to fork because it's pretty convenient. I don't need to do stuff. I don't know, I find it very convenient, and I better see things here. Hello Andrei, what are your thoughts on Rust perspective in 3 to 5 years? Oh guys, personally I don't know. I just know that in big corpus, at least we have some initiatives to change some services to Rust. I don't think I can say more, unfortunately. I personally never tried Rust. Get depths BCC is the way. What is get depths? Okay. Oh, Vlad, I don't know what is get depths. Are you talking about the problem? So back to the question about the Rust. I don't know. Mostly, I mean, at least when I started, my main was and is .NET. I find .NET one of the best languages. I'm sorry, but for the big projects and a lot of source code, I would say .NET is pretty good. For everything else, smaller, I would use JavaScript for sure, because it's quicker. And here for problems, we are using JavaScript because unfortunately .NET, I mean in the .NET that LeetCode is executing the source code, you cannot do this. And I want to initialize array quickly. And also JavaScript is used because you can straight away test your code here. Just press F12 and you have your own compiler in the same LeetCode tab, right? So that's why JavaScript, it's quick and convenient, and I like it personally more than Python. Python is very painful, I would say. I had some experience. Vanko knows, don't mind. Yeah, I see. This is something infra shit. Git approach. I see. Okay. Calculate the number of the same symbols. No. Actually, this problem is a bit harder than calculate number of the. It's kind of first step, I would say. Yes. Oh shit, we have 33 people. It never happened before, guys. It never happened. Okay. Yeah, so let's first solve the problem, and then we will get back to the questions. So yeah, first of all, from operation 1 tells us that we can rearrange the string as the way we want, so we can swap as many times as we want. It means basically so we can and this operation 2, when we can swap the occurrences of the characters between each other, it basically leads us to the from now your celebrity too. No, I don't think so. I'm boring. I'm not that funny as Vlad, unfortunately. So Vlad is very unique in this sense. But unfortunately, yeah, Vlad then doesn't do streams of LeetCode anymore, as far as I know, at least. Would be great to see these old times. Yeah, now I'm doing LeetCode streams. So yeah, the first naive approach in this problem, if we take a look into example 1, is just to count the characters themselves. We can use some set and check that two strings have the same characters. But it won't work actually. If we come up with some more sophisticated example, like this one, for example, these two strings, they also have the same number of characters. C, A, and B. Or let's put it a bit simpler, A, B, C, right? The problem is that they have different occurrences. They might have different occurrences of this character. So in this case, this input is okay because, yeah, it's proven that we can use two operations and convert the first word to the second word. But what if I would have, instead of two B's, I would have four C's. So A, B, and four C's. Can we do it in this example? We can run what they did and prove that we actually cannot do it, because there is no four same characters in the first word. So whatever we are doing, however we are like rearrange the numbers, we can put first string as C, A, A, and B, B, B. No matter how we swap the numbers, the characters, and how we change them, we will never get to the point of having four characters, or four same characters basically. So it turns out that apart from having the same characters in two strings, we also should ensure that all unique occurrences, or basically all occurrences in two words, are the same. So in case we have four occurrences of some character in word 2, we should ensure that first word also have the same amount of occurrences. So, few steps how to check it. First thing, we are checking the strings have the same size. Second, we are checking that both strings have exactly same characters. And third step, we are checking that two strings have exact same occurrences. And in this case, it can be proven that, yeah, we can basically convert word 1 to word 2, or in other words, these two words are close. So let's basically implement what we just said. But before implementing, since it seems like I now would need to answer some questions. JavaScript stdlib is terrible for LeetCode though. Yeah, for now the only one problem that I'm facing with using JavaScript for LeetCode is that JavaScript doesn't have priority queue. So it doesn't have heap. And this is the problem, because if we move forward, there are gonna be problems, trees, DFS, BFS, heap and priority queue. JavaScript doesn't have priority queue, and you cannot use a library. You cannot just npm install here. That's the problem. So for these priority queue problems, we're gonna use C# and .NET, because C# does have the max heap. Or maybe we will come up and I would just paste in the custom implementation of heap, because it's just array, right? Array with the specific operations. Vlad's aura and socials made you nervous. Well, of course, like this channel usually has like 6-7 viewers on the streams. For sure, I'm a bit more nervous. Well, it's terrible for everything, but LeetCode especially. Well, I'm not sure. Yeah, the only one problem is that it does not have heap. Other than that, I don't see any problem with JavaScript for the problems we're gonna solve at least. Now let's move on and implement. So I would implement it a bit in a way that I initially did, and then we can do a bit of adjustments and improvements on the code. So first of all, what we're gonna do is we're gonna check that two words are the same or not. So we can basically straight away check the length, but maybe we don't even have to, because anyway we're gonna check the sets. So we want to check that both words contain the same characters. How we're gonna do it? Pretty simple. It will be a bit longer source code, but then we would improve it. So this is basically initial version, which I would say it's better for understanding for now. So first of all, let's create sets, two sets from both words, and then check they are equal. So let's say we have some word as an input, and yeah, or maybe let's also collect the occurrences of this of each character as well, because we anyway gonna need it later. So why not? Let's start with the map straight away. Okay, and now let's just create them. Calling this func 2 times will give us the 2 maps, and each map would contain the unique characters in the word and the number of occurrences of these characters. Now, unfortunately, since JavaScript works as it works, we cannot check 2 sets like that, because it's gonna check whether the 2 instances are pointing to the same map or not, to exactly the same object. Even if the object contains the same elements, it won't basically help. So what we have to do is just to traverse one set and check whether another set has all the characters, and also check the lengths. So we straight away can say that if 2 sets have different sizes, we return false, because there is some character in one of the words that another word doesn't contain. So we would anyway not be able to construct the word 2 from word 1. These are not actually sets. This is, let's rename it. It's map 1, and this one is map 2. And now we're just gonna traverse it and check whether map 2 contains any character in map 1. Okay, this was some Vim magic. I'm sorry. Or in other words, I don't think we need to check whether it has. If it does not have, then we return false from this place straight away. Good. This way, now, at this point at line 18, we for sure know that these 2 words contain exactly the same characters. So, yeah, that's basically whatever we know right now. But in our example that we have provided, it does not necessarily mean that the words are close, because it can be A, B, 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 A, and A, B, B, C, 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 but 4 C's and just 1 B. We should check that both of these maps have the same occurrences. So if map 1, for example, or in this case map 2, how it would look like. So map2 for this word would look like this. So A is 1, B is 1, and C is 4, because we have 4 C characters in this array. And first word for it, the map would look like A has 2, B has 3, and C has 1. Yeah, so you can see that second word has occurrences equal to 4, and first word doesn't have it. It means we cannot do it. In this specific example, the occurrences are the same, because second word in this case would have 2 B's and 3 C's. So we have occurrence 1 in both maps, occurrence 2 in both maps, and occurrence 1 in both maps. So now let's check the occurrences as well. For this, let's also write some function. Again, it's this very bad code, but this is for simplicity and for understanding. Yeah, okay, it's gonna be map, right? Or not occurrence, maybe frequencies of map values. Good. And now, yeah, we're gonna add. What do we need? Map. Yeah, let's count them as well. So we're traversing both these maps. And just calculate how many occurrences we have, because why do we need to count the number of occurrences themselves? Because it can be, in this specific example, let me improve it a bit or break it a bit, I don't know. Let's add 3 E's here and there. So in this case we would have occurrences, 1 occurrences of A, 2 occurrences of B, 3 occurrences of C, and 3 occurrences of E. So basically it means that we can, yeah, I would put it in the sense that, yeah, these occurrences should be the same and they can collide. So we might have like 3 or 4 or 2 or 1 character of the same occurrence, and we should count them, because in case this E is dead, it means that here we have 2 occurrences by 3, and here we have only 1 occurrences of 3. And this will not work, basically. So we are counting the number of frequencies as well. Good. Now that we have both of these maps, so we have occurrences of characters themselves and occurrences of occurrences. Now we can basically check that these two also are the same, because we should have in the end the same amount of occurrences. So when we are doing operations, they in the end can create the word 2 from word 1. So we actually gonna check exactly the same way. We are checking first the length, size. Yeah. If it's not equal, we just return false straight away. And then we need to traverse and check every possible characters. This traversing is actually constant, because we might have maximum 26 items in the maps, since the input is only lowercase English letters, 26. And this how we're gonna do improvement a bit later. But for now, we're just gonna check key value of frequency map 1. If frequency map 2 doesn't have key from frequency map 1, or if it even has it, but it has different number of these frequencies, than frequency map 1, then in this case we return false. Otherwise return true. Yeah, very long code. Initially it seems like whenever I conclude that solution to some problem is this big size, usually it doesn't work. Let's check whether this shit works. Well, initially it does. Yeah, it does. It beats 75%, but this is bullshit, by the way. It depends between the runs. So I wouldn't use this as a benchmark. Let's calculate the complexity for this solution. So each map creation is basically should be, yeah, since we are traversing word array, let's assume that word 1 is n and word 2 is m. Since we are traversing the array every time we are calling this method, so these two gonna give us at least n or m complexity. So here I would say they are n plus m as a time complexity. And space complexity, you might think that it is also n because can be unique words, unique characters. But since we have 26 lowercase characters in English alphabet, right? So map can be maximum 26. Map maximum can contain 26 items. So 26 is space complexity. But since it's constant, it basically converts to all one. Yeah, and it should be 2 times 26. But yeah, these two numbers are just constant. It doesn't matter. Eventually it results to all one. Then this check is constant. Traversing all keys is constant because the number of keys is 26. So this is constant as well. Create char frequency map. Let's go to this method. We're just traversing our map, which contains maximum 26 items, so also gives us a constant time and constant space as well, because it produces another map. No, actually, I'm sorry. No, in this case, space can be different, because space, in this case, map would contain the frequencies, and frequency is just a number. Let's maybe check from the constraints that we have. Okay, so yeah, this map would contain all unique frequencies of the characters, which vary depends on the input. But let's assume, like worst case, it can be n plus m, right? So in this case, we would say constant as a time. But for the space, I don't think it's constant because it very depends on the input. So let's say it's all n plus m for now. Then we are traversing frequency map, which is kinda also all n plus n, as we decided as a time complexity. Right, yeah. Well, it will be for sure less than m plus n for sure it will be, oh sorry, not m plus n, just m. It will be for sure less, because in case we have, I don't know, let's say some string a, b, b, c, c, c. This string is which length? 1, 2, 3, 4, 5, 6, 7, 8, 9. The length is 9, but number of occurrences is 4. And this is the worst case, because these are unique occurrences. So it's a bit hard to calculate. I don't know if I add this here. Yes. So, but worst case, it should be less than n. Let's assume it's m. And then we return true. So add all of this up. I would say that's time it's n plus m plus constant plus m again, which in the end it would be resolved to n plus m. And for the space, I think worst case it's gonna be resolved to just O of m, because O of 26 is constant, we don't care. And map of occurrences, it should be below one of the words, I think. Yes. By that time, we for sure know that words length is the same. Yeah, so this is the solution, but yeah, it looks not that good, to be honest. How I can actually simplify it? We can leverage the fact that, let me drop this out completely. We can leverage the fact that we might have only lowercase English letters, which means instead of map, we can use array, because each character actually is represented by a numerical value, by the code. Now demonstrating the power of the JS, just F12, and I can show you straight away what does mean. So let's say we have character B, and we want to know its character code. So for this, JS has this function, it's 98. For character C, it's 99. For character D, it's 100, and it just monotonically increasing up until Z, right? And if we do this character magic, the entire solution is 3 lines in Python or Ruby, both of which have built-in equivalent of create frequent. Yeah, for sure, I understand this. But this longer solution is created for better understanding of what is going on. Because sometimes when you see these 4 lines optimized code, it takes like much more time to understand it rather than to write it. So right now we're gonna simplify it a bit, as I promised before, right? So first of all, let's talk about our character code magic. This is how we can work. This is one of the patterns, basically, how you could work if you know that you're gonna have only like characters instead of map or hash set or whatever data structure. You could use in this case array, because in this case you might map the character to specific index array and use it basically as a map, because accessing element by index in array is constant. Space pretty much same as accessing it from a hash map, right? So this is how we're gonna populate the hash set in this case. let's rewrite it in a way. So our set in this case is going to be an array of length 26 because English alphabet contains only 26 letters. We're going to fill it with zeros. Same thing going to do with array 2. And now what we're going to do still, this thing, how we're going to use this array is we can map the same characters to same positions in array, right? And then we're going to increase every time the same character we encounter the same character. So these two arrays, they are used basically to calculate the frequencies of the character. What's going to happen, we're going to iterate over character of both words. And then using our character magic that I just showed, okay, it can be 0. Okay, actually it might be without the index. This would give us index one of the from 0 to 25, because the last character that we could possibly get is Z, and yeah, it is 1 to 2, and for A it's 90 something, 97. So we perfectly can fit our map into two arrays. Yeah, we are doing exactly the same. Now these two arrays, they will have the occurrences, but since we might have the different frequencies of different characters, for example, we might have 3 C's, but we still have 3 B's here. So in case of array, let's say our B is 0 index or whatever. Yeah, so let's say the array contains like first 0th index for A, first index for B, and yeah, and second index for C. In this case, our array would have, in case of A, number 2, because 2 A's we just met. In case of B, 3 B's, and 1 C. This is for the first word. For the second word, it's different. For A, it's going to be 1. For B, it's going to be 2. And for C, it's going to be 3. These are definitely different arrays. But we can see that occurrences are the same, because we have one frequency only once, frequency 3 only once, and frequency 2 only once. How I can then easily compare the arrays in this case? Well, we can basically sort them. It will give us 1, 2, 3 for both arrays. And this is the trick, right? Because now we have two sorted arrays, and we can compare them by index one by one. And even though that character B here we encounter it only 3 times, and character C we encounter, and in the word 2 the 3 times encountered character is C. No matter, like we can basically disregard this fact, because the sorting would give us the same number of frequencies anyway, right? But in any case, complexity in Ruby is the same, even if you do it in 3 lines. Yes, that's for sure. Yeah, but yeah, you can build it much shorter with the shorter source code, right? And most probably complexity would be the same. But what I saw so far I don't know how many years, like I think I'm programming already 6 or 7 years. And what I saw so far, it's better to write more code, but much readable code. Better also for you and better for your colleagues. And that's why, so more audience can understand what we are doing right here. I'm not doing this 2-3 lines of complicated stuff. That is doing it in the same complexity for sure, but it's much more harder to understand these things, right? So that's why. Okay, back to our solution. This is the concept for the arrays, and this is how we compare the two arrays have the same frequencies. But now there is still a question that two arrays should have exactly same characters, because it can be that here we have not 3 C's but 3 D's, for example. In this case, our arrays would be the same, but actually answer should be false, because we cannot convert any of these characters to D, because this word does not contain D. That's why we're gonna still keep our set, and in the end we're gonna check whether one set has exactly same characters as another set. So first of all, let's sort our arrays. Now they can easily be compared. But before that, as I told, we should also ensure that two words have exactly same characters. So let's set one set. Let's just accumulate it. And we are adding okay, and now what's left here is to compare the arrays and compare the sets. Okay, so this should be the solution. Output. Okay, I think what we missed is to compare the size. Yep, I think this is the size. No, it's not the size. Okay, so let's find out what is going on here and why it does not work. So, yeah, I'm sorry, yeah, we forgot to increment every time we encountered the frequency. Good, now it should work. Yeah, it works. Regarding the time complexity, yeah, now it's pretty much the same, except I think for the now for the space complexity we optimized a bit. So we are using 4 extra memory. So these two arrays can be omitted to 01. Why? Because it's constant number. Even though it's big number, 26, it's still constant. So we perceive it as a 01. Then we are traversing towards fully, which gives us this one O of n and this one O of m for time complexity. And also the set maximum could have 26. So basically space complexity is 01 all the time, because set might have maximum 26 values, and arrays also can have only 26. Yep. Then sorting is interesting part, because in JavaScript I think, I don't really know what they use for sorting, but it can be maybe mesh sort. Oh, okay, I can actually Google it. JavaScript, what is used for sorting? Okay, let's even not Google it. Let's assume it's some mesh sort or I don't know, quick sort. So it would give us n log n, right? But since we are performing sorting of static arrays, the cool thing about constant arrays, constantly sized, that operations over them are also kind of constant, because it's going to be n log n, which is going to be 26 times log 26, which is constant. And then we are iterating constant times, so 26 items at most, also constant time complexity for this and for this 4. So yeah, overall the complexity would be, for time it's n plus m due to two traversals of input, and space complexity is constant. However, we're using two additional data structures. Okay, this was the problem. Now let's move on. I think we're gonna solve maybe this problem here, and then we can move on to system design, and then maybe as a follow-up one additional LeetCode problem to mix it a bit. So this problem, equal row and column pairs. We are given matrix n times n, and we should return the number of pairs where row and column are such that row and column are equal. Yeah, it's considered equal if they contain the same elements in the same order. So let's straight away consider second example. So in this case we have row 0 and column 0. So row 0 is 3, 1, 2, 2, and column 0 is 3, 1, 2, 2. Exactly same. And then row 2, 2, 4, 2, 2, and column 2, which is 2, 4, 2, 2 as well. And same one with the third row, 2, 4, 2, 2, and same column, 2, 4, 2, 2. So they actually can be reused. It shouldn't be explicit pairs. So if one row is bounded with one column, we cannot use this column for second row anymore. We can, as we can see. So what can be the brute force solution for this one? We can take every row, and for every row check all possible columns, basically all of them. It will give us not that good complexity, so let's think about the better solution straight away, because I think it's medium problem. Most probably we will hit time limit exceeded if we do some square time complexity here. So basically what we should do, if we would be able to check that both row and column are the same in some constant time, then, or not even the check, it will be always like the length of the matrix, right? But to find the specific row, for example, when we have 3, 1, 2, 2, it can be very large matrix, right? It can be length of 200. Yeah, so we have, let's say, row of length 200, and if we're gonna check every possible column, we're gonna check 200 columns, and this is for every possible row. This is very, very bad time complexity. It would be great for us to be able to get this column with length of 200, and then straight away in constant time to check whether there is any same column and how many of such columns there are. So this looks like hash set again. Exactly. Also, we are on the hash map /set topic. I think identifying the topic of the problem is already a problem that is halfway done on your interview. So this is mostly how you usually need to communicate during the interview, that yeah, we see the problem, we know how I can solve it brute force. Should I even proceed with this? Because sometimes interviewer is not even interested in brute force. He is interested in your more complicated or just more optimized solution, right? So in this case, whenever we have a row, how we can answer whether there is already some column? We can pre-compute them, right? We can collect all the columns before. But still, it will not answer like how we can build a hash map here. How we can put a row or column into hash map. This is the array, right? This is 1, 2, 3, 4. How we can put this into the hash map? Well, in this case, actually, I think it should be complicated to put it to hash map just as an array. Let's even try. Let map. What will happen? Yeah, map has just array. Let's set someone. Will we be able to return it? No. As you can see, it does not work with arrays because arrays are kind of reference types. I don't really see how it works. I don't really know how it works with JS, but we in .NET, what it would try to do most probably it would call getHashCode method, and this getHashCode would just get the object ID on the heap, which will be different for every single array, even if the arrays are the same. In a nutshell, yeah. So it will not work. What is the workaround we could do? We can serialize the row. By serializing, I mean we can basically put all the characters into the string and use the string as a key. This would be pretty much the workaround for this task. Or we can use native JSON stringify. Also could work. Yes, so how are we gonna proceed with the problem itself? First of all, we want to remember all possible rows, I think. Yeah. Let's first traverse all possible rows and remember which rows do we have in this matrix. So height of the matrix would be grid length. This can be a grid length as well. Now we're going to create our map and let's traverse all the possible rows. And now how we're going to add the row? As I said, we can stringify it. What it will do to it, I will show you right now. If we do JSON stringify stringify 1, 2, 3. It would produce a string that specifically represents the string representation of the row, and we straight away add it to our map. So rows. Good. Now we have collected all the rows. We can even try to run this code and see what our map contains. Just for the sake of example. What just happened? Yeah, the row would, oh sorry, there should be rows. Please, come on. So our rows map would contain the string representation of the row and the number of occurrences of this row. So in this case, we can see that 2, 4, 2, 2 is presented in the array 2 times. And now what is left to be done is basically to traverse the columns and check whether specific columns is contained in the map and how many times. So in this case, we would accumulate our rows here, and we can see that, for example, we have 2, 4, 2, 2 row twice. Then we go column by column, and at some point we would reach 2, 4, 2, 2, go to our map, see that there are 2 rows with the same value, and just add up 2 to our output. And before that, 3, 1, 2, 2, which you would get here, we would also go to our map and see it here. And this value will not be even used. So let's basically do it. Caps now. We are iterating over j, meaning we are iterating over the column. So this is going to be j is our column, and let's collect the column because our array represented in the way that we cannot just get the column right. We are serializing our collected column to be able to check the map, right? Stringify. And now we just increase our count. If the column that we are trying to get from the rows does not exist, we would just get 0 and it will not basically increase our result. Oh, sorry. The solution basically works. So let's try to analyze the complexity. The problematic part will be here is JSON stringify, but it can be simplified to just iterating over the over this row, element by element, and add up it to the string. So something like this. String, and then we go here. Something like that. But instead of this code, we just used stringify, which is serialization of the array. But we should remember that this is basically of m. In this case, I think grid is the same size, right? So it's always matrix with the same height and same width. Yes. So it means we have just n. We are traversing it once through the height, and then we are traversing it second time here by accumulating the row. Same thing happens during the serialization, I'm pretty sure. And then again we are traversing it here and here. So 2 for loops gives us actually n, right? No, it gives us n times n power of 2, because this is the length, which is 4, and we are traversing it 4, 4, 4, 4. 4 times 4, 4 power of 2. So time complexity here would be of 2 times n power of 2. And this get is constant since it's hash map, right? For the space complexity, it's of constant because we don't use any extra storage here. So yeah, we are accumulating column here to the separate variable. It can be maximum length of n, but we straight away forget about this variable after we go out of the for. Garbage collector would forget about the root of this variable and clean it. So by the end, it will be kind of clean. But we can also write O of n or O of 1 if we don't count this one. Okay. So did you submit it, right? I forgot already. Yes, so if you don't submit, let me submit once more. Yep, it works. Good. So now let's move to our most interesting section, at least for me, because LeetCode, I don't really like LeetCode. Personally, I would want it to disappear in algorithms because I'm very bad at LeetCode. That's why I'm putting much more effort to the LeetCode rather than to some other interview parts. And now what is going to happen, we're going to do system design of rate limiter. Personally, I never was asked to design a rate limiter, so I'm gonna do it for first time, kinda. But yeah, it's gonna be pretty easy system design. But we would go through it and we would design it in the way that pretty much every interviewer expects you to design it. So it should be, as always, highly scalable, highly reliable, reliable. So it means if you lose some node, your service as a whole should keep working. If you have increased load, your service should be working. Yeah, like 1 million requests, something like this. Usually these are the requirements. And before we start, I think I would I would have a bit of break. So 3-minute break for now. So yeah, let's meet in 3 minutes and we're gonna design this rate limiter. I think, yeah, could be interesting. I had already only 2 system design questions, and for both of them I got pretty good feedback comparing to LeetCode questions. So yeah, see you in 3 minutes. Okay, so I have my team. We're kind of done with LeetCode. I think maybe we will do one more follow-up question that was asked during previous stream, but for now, let's focus on the system design. So, let's assume you're on an interview and your interviewer is asking you, okay, you want to implement and to design the rate limiter for the highly scalable environment so our other services can use it. So you should first start asking questions like, what is this service about, how it should work. So usually a rate limiter is the service whose responsibility is to not allow the users or the clients or other services to use and to process requests more than you decide. So rate limiter is kind of middleware before your actual production service, and this rate limiter decides whether your request is going to be processed or not, depending on how frequently you are using the service. This prevents you from different attacks, first of all, because you can have DDoS, right? Also, another use case for this should be so that some specific user does not overuse the service, and so the service stays available for all the users, right? And another case could be when it's kind of business justification for it. So you, for example, might not allow the user use some feature more than some amount of times, but usually this should be a business logic, right? Usually the rate limiter itself is more about infrastructure and more about non-functional requirements. So for example, I'm the service and I want to allow some specific user to send me only 100 requests per minute and not more, because what's more, I think it's some very suspicious behavior, and from security standpoint and from the health standpoint of my service, I should block the subsequent request. This is kind of defensive thing that helps you to keep your service up and helps your service to operate in a healthy way. So usually what is the ways you can do it? I can say since I'm already working on a highly distributed system, my team based in Prague is doing this presence API. So presence API is the thing that shows you whether you're online or offline or away in the Teams, Outlook and stuff like that. So we kind of highly distributed and service with high load. So usually how the services can defend themselves, you as a service, let's say this is the service instance, and usually how it works, your service instance is basically something called compute. Usually you separate your computational thing and storage, because compute is compute. It's at least most probably you want to do it stateless, and you basically don't care about compute in terms that it goes down or you add additional instances. You can play with it as much as you want until you have enough computes deployed to handle the whole load. So the basic defense strategy is to put your rate limiting middleware inside your business logic, so inside the actual production service instance that handles the actual request. So you have some kind of middleware, and this middleware have in-memory kind of rate limiting, I don't know, class, service, method, function, whatever, and it maintains the different clients or different IPs from where requests are coming, and it does all things that we're going to decide right now, but it does it in memory. What is the problem with it? with that, it's actually, since usually in distributed environment you have a lot of such instances, and let's say for specific client or for specific user, I don't know, I want it to be 100 requests per minute, let's say. This is my boundary. The problem is that if each service allows me to send 100 requests per minute, and after that I'm getting throttled, if I start sending like thousands of requests straight away, let's say we have some load balancer here, right? That directs and proxies the request from the client to the specific service instances. The problem with this approach that if we are doing it per user, in our case per IP or per user token, whatever. So if we are, our dimension is user, not the client, which is application or other service. So per users, if I start sending like 1K per minute, it will get to the rate limiter like this one, and usually load balancer does this in kind of random way. There are different algorithms, but let's assume it's random way. So at this instance we reached 100 and we return 429, which is too many requests response. But then load balancer can conclude to route the request here, and here we have 0 out of 100. So in the end, yeah, I will be receiving some of the 429s, but in the end I will be able to send 300 requests to every instance up until I'm getting fully blocked, and up until I'm getting 429 100% of time. So it means with this approach each single user can do 300 requests, however our limit is 100. So this kind of approach is good in terms of service-to-service communication. Whenever your service has communication or it has some inbound partner, so let's say my service is receiving requests from another production service from another team, we can configure our rate limiter to be bounded per client or per service, and to allow this service to send specific amount of requests. Let's say our inbound partner, it's also like highly scalable system, and it also receives 1 million requests, which in the end are converted to, let's say, 100,000 requests per minute, let's say. So in this case, we want to configure our middleware to allow 100,000 requests per minute from this service, but service as a whole, not per user. In this case, this technique would work, kind of. But let's now think about a bit more general solution for distributed environment, in which you don't have to even touch your production services. So let's say, let's first of all, let's draw some boundary. So let's say we have some production service, and we would like from this production service to set the rate limit rules per user. Let's say this is the requirement from our interviewer, right? We are drawing boundary here, or maybe not even here. I think here, yeah. This is the things we don't have access to. So this is production service, this is kind of our client. And this client asks us to do a rate limiting of the requests in the way that every user might perform, let's say, 10 requests per second. Per second per user. Yes, exactly. How I would build such system? And this production service, it expects 1 million requests from different users. Let's say it has user base with 500,000 users, right? So before going deep inside the different concepts of distributed systems and stuff like that, usually what interviewer wants to see is some basic high-level overview, basic thing how it should work. And usually you don't need to think about highly scalable, highly available. First of all, to simplify yourself a task, you need to design a single server solution and prove it that it will work. And then you can work on non-functional requirements like scalability, reliability, maybe consistency if you need to, and stuff like that. So how it would work in case I don't have 1 million requests and I have like 1,000 requests per minute, let's say. So it's pretty doable for one single server. So let's say we have our rate limiting API. And let's draw it. Rate limit API. This is HTTP server. It would work kind of as a proxy. So let's say we have some client, which can be browser, mobile, it doesn't matter, some client. Web, mobile, etc. And we have a lot of users. And they are using this client to operate with production service, right? So the communication would work in this direction. First, client calls our rate limiting API, which serves as a proxy kind of. And rate limiting API decides whether to proxy the request forward to the production server and serve the request, return the response to the client. Or if rate limit reached, we can, not we, but rate limit API can decide to drop the request and return 429, which is too many requests. Sorry, you should wait. This is the basic, simple approach. Yeah, and yeah, that's basically it. This is the high-level architecture, but now let's think about how in the single server with the single endpoint, we are going to decide whether the limit is reached or not. Let's say we have these 10 requests per second. How from the code perspective we can do it? It should be per user also. So since it's going to be per user, we should either have some token from which we can get the user ID or something like this, or we can use the user ID as a IP, which is not always the user, because IP can be changed through the VPN and stuff like that, but we definitely need some identifier of the user. And you should ask your interviewer, like, what should be the identifier of the user? Should it be, I don't know, some user ID from token, user ID from header? Maybe we should just assume it is IP and stuff like that. But let's assume it's IP, and our users can be not authorized. In this case, we can, in memory, keep some kind of map that would contain IP, which maps to the user, and this IP would contain number of requests that this user already performed, and also start time. This technique calls somehow like static time window or whatever. Let me Google it. There is a specific algorithm for rate limiting. This is a bit inside. It does not really. We do not really need it for the. We do not really need it for our system design. But just for the sake of to be clear and to explain stuff. Yeah, this thing called static window rate limiter. So how it works? We keep our map. We can access the user by the key in our case IP, and we can access the user's data. In our case, we do care about number of requests, and we do care about when was the last time, or in this case, when was the last time window, because let's talk about it a bit more. If we are talking about rate limiting requests per second, it means we can assume it in some kind of segments, in the sense that each segment is 1 sec exactly, and so on. This is time, our time frame, and we want to ensure that during this 1 second we had maximum 10 requests. They can land in different places, right? But we want to ensure that it's 10 requests. So how we can ensure it, even in not distributed environment? We can maintain this map, and we can maintain the start time of the first request that came from this user. Let's say user never called this service before, and this is exactly the time the first request landed from IP, I don't know, localhost, whatever. We start our map and we write in this IP with the number of requests 0 and start time 1. Let's say it's gonna be 5, oh no, it's gonna be 2, it's gonna be 3, it's gonna be 4 seconds. These are seconds. Then user, let's say, sends 2 more requests here and here. What's going to happen during these 2 requests? So for this request, we already know that map contains the information about this IP, and number of requests before was like 0. It means we just get this API, and by using atomic increment, which is specific CPU operation for the concurrency, we increment this counter by 1 because there is 1 more request, and that's it. And since the number of requests less than 10, we allow this user to hit production. Then this request happens. We can go, we see that this record exists, we do increment, we go further. Then we reach at some point second. Okay, and we are at this point, right? At this point, this is our 3rd request from this IP. But it should be a different second bucket, right? Because previous second already done, and if this second already used 10 requests, the new second should allow user to send another 10 requests, right? In this case, what's going to happen in the application logic that we are taking this record and we always check that start time, otherwise, let's say this is going to be now, not how, but now. And we are checking that now minus start time, if it's, in this case, it should be bigger than bucket. In our case, bucket, let me write it the right way. So every time we are hitting, we are checking whether time, whether now minus start time of this record, so the first request from the user or the first request in the window, our window is 1 second, is more than 1 second. If it's more than 1 second, then we already used the previous window, and we should update the start time to now. Or, yeah, basically we should update it to now. Let me pass it. So now minus start time. Just here it's gonna be, yes. So what's going to happen? We are starting our bucket right now from different place, which is this one, and this is gonna be the first request in the new bucket. So these previous ones, they are dropped. And we are starting the new one. And all these requests, they are also keep going up until we reach another second. Once we reach second, we kind of discard. Maybe I'm explaining it a bit in the hard way, but let's try again. So we have our map, let's just run our algorithm. We have our time frame. And let's say this is 1, this is 2, these are seconds, 3 and 4. We have our map. And we have our local host that has data, that does not have data at all for now. We hit our first request here. By the local host. We go here, we see that there is no data for now, and we are filling it with the number of requests equal to 1, because this is the first request, and window start equal to, I don't know, this should be, let's say, is 0.1 second. We will not be working with the seconds, we're gonna work with the timestamps. So this unique timestamp, which is number of seconds starting from 1970 something. So our window start gonna be 0.1. User keeps sending requests. All of these requests gonna be accepted. Let's say we increment 1, 2, 3, 4, 5, 6. It's gonna be 6 requests. All is good. All is good. We are not overflown. We can proceed. Then at some point it's gonna be 1.1 second, and let's say the next request happens here. 1.3 second. In this case, we are taking the record from the map, and we see that now minus window start more than 1 second, because 1.3 minus 0.1 more than 1.0. Right. Pretty makes sense from the math standpoint. Now, if we see that that's true, we're gonna reset this map completely and set it to 0 again. Sorry, to 1, because this is the first request. And Windows start now is going to be 1.3, because this is our 1.3, the new request in new bucket. And this is our new window, or otherwise new bucket, and we keep adding the requests. Let's say we reached 10 requests and gonna add 11s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This window should stop actually at 2.3 second, which is somewhere here. These requests are valid because these are 10 requests, and let's say we are hitting 11s. So by the time we are hitting 11th requests, remember our requirement is 10 requests per second, we're gonna see that yeah, this is 11th request. We already have 10 requests. This is not true anymore, because let's say now is 2.0 and start window, our previous start window is 1.3, and it's not more than 1, so we're still in the right window, and it's 11th request. We're gonna forbid it, so we're gonna reject the request with the 429 and tell the user that please, you should wait a bit, don't overload our service. The user waits for some time, and then it performs requests after 2.3. We read this value and we see that 2.3, oh sorry, not 2.3, but let's say it's 2.4. The 2.4 is actually more than 1 second, so it's gonna be new bucket. We're gonna recreate it. Windows start gonna be 2.4 and number of requests gonna be first request. That's it. This is how it's gonna work. We just keep this map in memory, read limit, API, and all should be good. But let's think about now non-functional requirements. So this is kind of proven it's gonna work. It's gonna work even in concurrent environment. You might use atomic increment, and this is CPU operation in case you're gonna access the same variable number of requests concurrently. I will explain. So let's say you have 2 users and they at the same time want to increment number of requests. So with the regular operation, you just read this number of requests, which is going to be 1. For each user in a good normal servers, it's going to create for the separate threads. Let's not talk about input-output operations. Let's say it's CPU-bounded server. It's going to create separate thread for each user. So this T1 and this is T2. And this thread 1 gonna read number of requests, which is going to be 1, and gonna increment it, which would result in 2. Same thing gonna do thread 2. It's gonna read the number of requests, increment it, and put back 2. In this case, the result would be that number of requests is 2, but actually it should be 3 because 2 requests happened since the last time. And how people overcome this problem, they use atomic increment. This is specific CPU operation that is doing atomic increment in the way that it will never lose the value. So it means it always increment only by 1, no matter what is variable, what is the variable right now. So instead of read and update, it just updates no matter what is read. And this is not accomplished from the code. It is accomplished on the low level as a specific CPU operation. We have it in, I think, every language, but I can Google it for C#, atomic increment. So for C# we have, for example, for .NET we have interlocked increment. In the concurrent environment, it will increment it correctly. And the same thing, for example, Postgres has, because in the Postgres, let's say you decide to store some same counter that should always be incremented in a Postgres. So SQL also has atomic increment as well. So this is kind of already solved problem. And with this atomic increment, we can also prove that concurrently it should work, right? Now let's think about these two, highly scalable and highly reliable. What highly scalable means? Highly scalable means that if we have 1 million users and each user should have this requirement, 10 requests per second, most probably 1 million requests, it's something not doable for the single server. Hi, sorry, are you planning to make a video about interviews at Microsoft? Maybe you're already an interviewer at Microsoft. Well, yes. I I performed one. So at Microsoft we have specific procedure. You cannot just start interviewing like out of nowhere, right? We have hiring events where we are interviewing candidates, but for that you should pass the courses, the specific trainings that I already passed, and before you can be a main interviewer, you should shadow a couple of interviews, not a couple, but I think starting from 5. And I already shadowed, I think, 5 or 6 interviews, and one interview I performed on my own with the reverse shadow. Reverse shadow is where I'm, as a guy who is learning how to interview, is performing interview, and I'm shadowed by somebody stronger with a lot of experience and stuff like that, and he's supervising me during this process. So yeah, so technically I conducted one interview at Microsoft, and yeah, there's gonna be one video about it for sure. Thank you for the question. So since 1 million requests are this is something not doable for the rate limiting API, right? It means we would need a bunch of these APIs, and we want them to be flexibly scalable. So let's say we're using some Kubernetes or whatever else. Maybe we are using some cloud and we just don't care about it. It is provided out of the box, but we are able to increase and decrease number of replicas here, so number of computes. So now for this to be working, we should put some kind of load balancer here, and this load balancer knows about all of these APIs. And client talks about, oh sorry, not about, but client talks to load balancer in this scheme, and load balancer knows about every possible rate limiting API. This is kinda ensures that you can handle unlimited amount of requests depending on how much money you have. If you have infinite amount of money, you can scale infinitely. So let's say one rate limiting API can handle, I don't know, 10k requests per second. Then you would need 10 requests per second and divide 1 mil by this 10k, and you would see how much servers do you need. So you need 100 servers. So you can scale 100 servers, and you will be able to handle 1 mil requests. For the spikes it will not work, but if you have pretty good load balancing technique, well, you're okay. If we keep our algo in memory, in this case, what will happen? Let's say we have this hash map in every rate limit API. Then the problem here is the problem that we already described. No, we didn't put it anywhere. So when every single instance has own hash map, how does this instance know that this hash map is not already overloaded in other instances? So let's say this rate limit for local host, it receives 100 requests already, and now the load balancer landed the request from localhost to this rate limiting API, and this map is empty right now. It will allow this request, and it will break our invariant that we should keep 10 requests per second per user, right? How are we going to accomplish this problem? Also, another problem with scaling right now, that if one instance goes down, we kind of don't care because we have another instances to catch up with the load. But if this instance contains the number of requests that were performed by localhost, it does not have it anymore because we are doing it in memory. So instead of memory, we should get some storage for it, so kind of single storage. So every rate limiting API can talk to this storage, and this storage should be fast. because latency is the key for rate limiting, right? This storage should be fast, and it should not be that much durable, because we are interested mainly in 1 second interval, right? So whatever is already happened 10 seconds ago, we don't care. So it should not be that durable. So according to requirements that I just stated, it should be cache. Let's say it's gonna be Redis. So we're gonna just put the Redis. And this Redis would have exactly the same map, because Redis is key value storage, right? So it can contain some data structures based on key. For already existing problems like increment and stuff like that, Redis already has all of these operations in place natively. So first of all, you could put a key and value for some Redis, and you can put the expiration time for this value, which means if I want, for example, to put to the Redis key with number 1 and put some string, I don't know, QWERTY, I can set that this key should live 10 seconds, and during these 10 seconds, Redis would return value with the key 1. After 10 seconds elapsed, so expiration is done, this value will be dropped automatically. So it simplifies our problem even more, because we can basically don't even check this environment anymore, because we would know that after 10 seconds the key will not exist, and our new request just would go to Redis and create another key. That's it. We can just put expiry 10 seconds and it will be dropped automatically by Redis. So Redis is kind of ideal choice for us in this case. So now all of these rate limit APIs are going to talk to Redis. Let me put this one. They're gonna use exactly the same algorithm and use exactly the same operations as we did for in-memory version, but now it's going to perform it for Redis. Now Redis is kind of our single point of failure. I'm not sure about Redis capacity. We can run some benchmarks. It depends also on which server the Redis runs, how good this server vertically scaled. But let's say Redis also should be scaled to handle all the volume. So if you're talking about some cloud provider, they most probably suggest you, or they have option to partition your Redis to some shards. So you would have, instead of instead of one Redis, you would have 2 Redises. Oh shit, okay. And these Redises would split the whole keys. So let's say all keys from, I don't know, 1 up to 500k go to this Redis, and starting from 501 up to 1 mil, it goes to this Redis. So we also can scale Redis, and that's all right. Scaling point is kinda done already, and it's kinda solved at the moment. You can scale Redis, you can scale your APIs. It should be working, as we proved already. Now, how you can do highly reliable part. This is non-functional requirement as well. And for highly reliable, let's talk about APIs. So our APIs are fully stateless, which means we can drop any of them and spin up another one instance, and it will be working exactly the same. Is all right. So reliable, in terms of reliability, our API already supports the reliability, because we can drop any of the instances and system will keep working, because they are stateless. Now, what about the reliability of the Redis? This is the more interesting parts, because reliability of storages is a bit more complex topic than the reliability of the computes. Let's talk about the Redis. The typical pattern for the reliability for storages is the replication. Of course, we have three types of replication. The master-follower replication, when we accept write by single Redis, and we replicate these writes to any number of instances of the Redis. So in case of leader failover, let's say this is the leader and this is follower, so writes are accepted and reads also possibly are accepted by the leader, and they are replicated or replayed to the follower, and follower can accept only reads. So in this case, leader is down, our rate limiting API can go to our follower and start reading and writing to it. But for that, you need to implement leader election, blah, blah, blah. It is also mostly already done and implemented in any cloud provider for the Redis. So you should be good with this. Another option for the replication is leaderless replication. This is when your client decides where to write and where to read. Basically, for leaderless, you know your specific client, which in our case is rate limit API. It knows about all of the replicas, and it tries to write to all of them and tries to read from all of them. Usually you have some quorum. These are details, but basically the quorum states that you should have number of successful writes plus number of successful reads more than number of replicas. So in case of 2 replicas, it's kind of meaningless, but if you have, like, let's say 4, then you can ensure that if you have 3 successful reads and 2 successful writes somewhere, anywhere, you can kind of prove that your system gonna work consistently and you're gonna get consistent results. And the last one option for the replication is masterful. So master-master replication, when both of your instances are accepting the reads and writes equally. But there, in this case, you might have conflicts because, when your 2 instances are independent and some of them can randomly go down and come back, in the end, you will be in the situation with the conflicts, and you should already think about it and think about how you're gonna solve your conflicts and fix them. For our case, for our pretty simple case, I'm pretty sure we can go with leader follower. So leader accepts writes and reads. We don't really care about durability. If we even lose this data, we're gonna let some requests through and recover pretty fast, right? So in case leader is down, our cloud provider would run leader election. It will elect this follower to leader, and this leader would be killed completely, and we will spin up another read replica and start syncing data to this follower. That's basically it, and it's going to be pretty enough for us. At some point, we might lose access to the 2 writes, but it will be recovered pretty soon once the leader election is happening. I think this can be pretty satisfying answer for the interviewer in this case. We can think about different options, different replication in case you need to. So this way we kind of prove that our system is going to be reliable, because we can easily drop some rate limiting API and nothing will change. Same thing we can do with the Redis. As once we lose this Redis, the follower would be elected as a new leader, and we will continue operating as usual. Now, Yeah, okay, so now we kind of satisfied all our requirements. Now we can have some follow-ups, like where do we put, how do we distribute our system, how we're going to deploy. So for example, if you're deploying only in Europe and you have some users calling your service from USA, then yeah, you should deploy also in USA, because otherwise latency would be huge and your rate limiting would be more like bottleneck rather than something that helps, right? This can be the follow-up. Another follow-up can be, for example, how do we update the configuration, right? Because our production service, let's say, first we decided to have 10 requests per second per user. Then our client decides, no, we want 2 requests per second per user. How are we going to update it? So in this case, the follow-up, usually, at least from my experience, how we are doing it in distributed environment, you have something called configuration service. And it works with the push strategy. So instead, yeah, so it is on our side actually. And how it works is that our production, we expose API for our customers, which is production service, and this API can update the rate limiting configuration, also including the rate limiting window. So instead of 10 seconds, it's gonna change to 10 requests per second is gonna change to 2 requests per second. And how this config service might work, since we have a lot of instances, this config service does service discovery, so it decides which of these rate limiting APIs are available, and it can basically inject the configuration update to every single rate limiting API. And with this injection, they can either modify the map or wait until the map is expired. And then after some time, when all previous buckets are expired, it's gonna working with the 2 requests per second instead of 10 requests per second, because configuration service already updated this configuration for every rate limit API. And yeah, once new rate limit API spinned, it just goes to this config service and pulls all the configuration, or all of them are polling the configuration once per 2-3 minutes to be up to date. This is in case this config service cannot reach the rate limit API. This can be the follow-up, for example. What else? I'm not sure regarding the consistency. In this case, I don't think we care about consistency that much, because here we can maybe let some more requests than needed. In this case, we kind of accept it, but overall our non-functional requirements are kind of fulfilled in this case. Yeah, pretty simple system design, one of the easiest questions actually. You might be asked even to implement it, like this algorithm with map and stuff like that. I'm not sure should I implement it right now or not. It shouldn't be that long. Maybe we can leave it for next session if somebody would want to. We actually, to be honest, we actually can implement this system design. It should be very simple. Just write our services, spin up Redis, spin up, like put it into Docker, run some Kubernetes to spin up all the instances, and then use K6 to run benchmarks and see if it works. Actually, we can do it next time if you would like to see it. Yep, other than that, I think we're kind of done for today's stream. How much we are streaming already? 2 hours, yeah, 2 hours, 0.3. I think, yeah, we should be done. I think all this extra problem will be done next stream actually again. We are postponing and postponing. Yeah, this stream was excellent. For all new people, thank you that you came here. Hope it wasn't that boring and bad. So next time, next Sunday, I'm waiting you. We're gonna do again LeetCode and some system design. We can talk about, I don't know, Frank, the life as a Microsoft engineer. You can ask whatever you want. And yeah, for now, I think that's it. Please don't forget to subscribe to Instagram and Telegram. We are doing polls there, so we are voting for the next content and stuff like that. So don't forget to subscribe, please. It was me, Andrei, with you at Microsoft Office, Sundays evening. Thank you again, and see you next time. Bye-bye.